In our next section, we're going to talk about NAT, Network Address Translation. And let's go ahead with the NAT overview. Network address translation is the method of remapping one IP address space into another by modifying network address information in IP datagram packet headers while they are in transit across a traffic routing device. The main use of NAT is limit the number of public IP addresses as an organization or company must use for both economy and security purposes. So why we need NAT? Because IPv4 address space is limited, so each device cannot use a global address, and private IPv4 address range is not routed by internet routers, so they need to be translated to global addresses. Let's go ahead with the private IP address range. A private IP address is an IP address that is reserved for internal use behind a router or other NAT device apart from the public. Private IP addresses are in contrast to public IP addresses, which are public and cannot be used within a home or business network. Sometimes a private IP address is also referred to a local IP address. Okay, we have class ABC IP addresses, as you can see, and these ranges are the private IP address range that we can use in our local area network. Let's go ahead with the NAT terminology. In NAT terminology, we have some terms such as inside global, for example, inside local, which means your host IP. For example, if you are on PC1, your inside local IP is the IP address of the PC1. Let's go ahead with the inside global. Inside global address means your public IP address. In this statement, in this example, our IP address, inside IP addresses are converted to this public IP address. So which means our inside global IP address is this. And we have outside local IP address term, which means remote host IP. In here, the remote host is this, and our outside local IP is this IP address. And outside global address is the remote public IP address, which is this IP address for this example. Let's go ahead with the NAT types. We have three types of the network address translation, and they are static, dynamic, and the PAT, which is port address translation. In static NAT method, private addresses are matched with global addresses 1 to 1. For example, if PC1 will go ahead to the internet, that's gonna use this IP address. If PC2 will surf on the internet, that's gonna use this IP address, and PC3 will use this IP address. In dynamic NAT method, a public IPv4 pool is configured on our router, and IP addresses are assigned with first come, first served rule. For example, if this guy wants to surf on internet, he'll get this IP address from this pool. If secondly, PC3 wants to surf on the internet, this guy will get this IP address, And if PC2 wants to serve to, that's gonna take this IP address. Let's go ahead with the port address translation. In path method, each private address is translated to a single or a few public IPv4 address, and port addresses are used for choosing the right internal device when the packet is coming back. In this method, we have PC1, 2, and 3, as you know, and all of these guys have the private IP address of this, and this for each PC, and we just have one public IP address, and our private IP addresses, all of them are being converted to a single IP address in path method. Let's go ahead with the NAT configuration. To configure a static NAT, we are typing IP NAT inside source static, and we are typing our private and public IP addresses that we want to convert. Then we are getting into the interface mode of our router, and for gig 00, which looks to the internal side, we are typing IP NAT inside command, and we are typing IP NAT outside command for our gig 01 interface, which looks to the internet side. To verify the static NAT configuration, we can use show IP NAT translations commands, and we can check the inside local and the global IP addresses. Let's go ahead with the dynamic NAT configuration. So we need to firstly define an IP address pool in here. To define a pool, I'm typing IP NAT pool, the pool's name, which is network.el, and I'm defining the range of the pool with the net mask keyword, and I'm typing the subnet mask that I'm gonna use for the pool. Then I'm creating an access list, and I'm permitting my internal network, which begins with 1041.1 in here, and I'm using with the proper wildcard mask. Then in the third step, I'm typing IP NAT inside source list, the access list number, with a pool of our pool's name. Then in the last step, I'm getting into the interfaces gig 00 and gig 01, and I'm typing the IP NAT inside and IP NAT outside statements. Here's the configuration of the path. For path configuration, we are using the similar logic with the dynamic NAT. We are creating a pool again with IP NAT pool name, network path, and we are defining the IP address range, which are the same ones because I'm just gonna use one IP address with this subnet mask. Then I'm creating an IP access list again, which is defining my local area network. Okay, the IP addresses that I'm using are just starting with 1041.1, and this access list hits these first 3 bits and hits the statement starting with the 1041.1. Alright, then I'm typing IP NAT inside source list, ACL number, pool, my pool name, and I'm using an overload keyword. Okay, that's the key difference. Then I'm getting into the interface modes, and I'm typing IP NAT inside and outside statements again. So let's take a look to the NAT for IP version 6 lastly. IP version 6 has a huge address space, so there is no need for NAT for private public translation. NAT is only used for communication between IPv4 and IP version 6 devices, and this method is known as NAT 64.